You know, AI is already making huge decisions about our lives. Think about the news you see, or whether you get approved for a loan. But here's the thing. There's a really big problem hiding in the code. So what happens when these incredibly powerful systems are, well, secretly unfair? That's what we're going to get into. We're going to peel back the layers and look at AI's hidden biases and why its judgment isn't nearly as objective as we've been led to believe.
All right, let's just dive right in with some real-world examples. Because, it's one thing to talk about bias as this abstract idea, but it's something else entirely to see how it actually impacts people's lives. And these next few examples, man, they really show just how high the stakes are.
So let's take a look at the US criminal justice system, for example. There's this algorithm called Compass, and its whole job was to predict how likely a criminal was to reoffend. Sounds useful, right? Well, a huge investigation found that it was almost twice as likely to incorrectly label Black defendants as high risk compared to white defendants. And I want to be super clear here. This isn't some random glitch. This is a bias that has a massive life-altering impact. And it's not just in the justice system. How about the job market? So get this. Amazon built this AI tool to screen resumes. The idea was to find the absolute best talent out there. But what happened? The system basically taught itself that male candidates were better. How? Well, it learned from a decade of Amazon's own hiring data. And it started to actually penalize resumes that had words like women's on them. It was literally downgrading qualified female applicants.
And it can get even more personal, affecting the technology that you and I use every day. You've probably heard about this one. It was a pretty infamous case. Google's photo algorithm actually mislabeled photos of Black people as gorillas. Now, this wasn't some evil programmer's idea of a joke. It was the direct result of an AI that was trained on a dataset that just wasn't diverse enough. And the outcome was, of course, deeply offensive and incredibly harmful. So, you have to be asking, how does this keep happening, right? I mean, these aren't just a few isolated glitches. They're all symptoms of a much deeper problem. To really get it, we need to go to the source. Let's diagnose the roots of this unfair AI.
Okay, so this is really the core of it all. AI bias isn't about random mistakes, it's systematic. Think of it like a loaded dice. It's a consistent pattern of unfair discrimination where the AI just keeps producing these unjust outcomes that hurt specific groups of people. And what's worse, it often ends up amplifying the inequalities that already exist in our society. And this slide just illustrates it perfectly. The problem really starts in two places. You've probably heard the phrase garbage in, garbage out. And that is exactly what's happening here. The AI learns from whatever data we feed it. And if that data is flawed or biased, well, the AI is going to be flawed and biased too. But it's not just the data. It's also the assumptions we, the humans, build right into the models themselves. That can also create or even magnify bias. Okay, let's break that down a little more. There are a few key types of bias to know about. First up, you've got data bias. This is when the training data just isn't representative of the real world. A classic example is facial recognition trained mostly on lighter skin. Then there's label bias. This is sneaky. It's when our own human prejudices get encoded into the data labels. After that, you've got algorithmic bias. This is when the design of the model itself, the choices the creators make, favors certain outcomes, like a loan algorithm that prefers people from wealthier zip codes. And finally, there's societal bias, which is maybe the trickiest of all. This is when the AI just reflects the historic, systemic inequalities that are already out there in the world. Okay, so if that's the diagnosis, what's the treatment? Is this a lost cause? Well, the good news is no. Developers and researchers are definitely not powerless here. There are actually concrete ways to fight back against bias in AI. The whole key is to intervene. And what's great is that there are multiple points where we can step in. We can try to fix the problem right at the source before the model is even trained, or we can make adjustments during the training process and even after. So this pipeline here shows that strategy in action. First, you can start at the data level. You fix the data at the source, making sure it's diverse and actually represents the real world. Then there's pre-processing. Here, you can modify the data set before training, maybe by reweighting data points from groups that are underrepresented. And finally, you have in-processing. This is where you actually get your hands dirty with the learning algorithm itself and tweak it to optimize for both accuracy and fairness. But, and this is a really big but, this is where things get really, really complicated. Trying to fix bias isn't like flipping a switch. It opens up this huge, messy, ethical can of worms, starting with one very basic question. What is fair? anyway? And that really is the million-dollar question, isn't it? Because there is no single, universally agreed-upon definition of fairness. What seems fair to one person or in one situation can look completely unfair in another. Let's look at two competing ways of thinking about this. On one hand, you have what's called individual fairness. The goal here is simple. Similar individuals should be treated similarly. Makes sense, right? Like two people with identical financial histories should get the same loan decision no matter their race. But then you have group fairness. This idea says that different groups should have similar statistical outcomes. For example, a company's hiring algorithm should recommend men and women at roughly equal rates. Now here's the problem. Trying to achieve one of these can sometimes make it impossible to achieve the other. You can't always have both. And that brings us to this central dilemma, which is often a direct trade-off. A lot of the time, when you push a system to be more fair by one of those definitions, its overall accuracy, its ability to get the right answer, actually goes down. You are literally forced to make a choice between fairness and accuracy. So that forces us to ask some really tough questions, like this one. Would you accept a 5% drop in accuracy to reduce racial disparity in a predictive policing system? Wow, what's the right answer there? What are we as a society willing to sacrifice to get a more equitable outcome? Is a little less accuracy an acceptable price to pay for a lot less disparity? There's no easy answer. And that's a question for all of us, not just the people writing the code. So, given all this complexity and the very real potential for harm, where do we go from here? Just hoping for the best is clearly not a strategy. And that's where the conversation has to turn to rules for the robots. In other words, regulation. Look, when you have AI systems making massive decisions about people's rights, their freedom, their opportunities, you just can't leave that in an unregulated Wild West. The potential for serious harm, we're talking discriminatory hiring, wrongful arrests, mass surveillance, it's just way too high to ignore. The whole point of regulation is to create some guardrails. It's about setting clear rules of the road to prevent discrimination in really important areas, like hiring and lending. It's about protecting our fundamental rights from being misused by things like mass surveillance. And really, it's about making sure these incredibly powerful tools are used ethically and safely, and to fight things like the spread of misinformation from deepfakes. Now, let's be realistic. The goal here probably isn't some impossible state of perfection. We might never be able to eliminate bias completely, just because it's so deeply baked into our data and our society. But we can manage it. And we do that through things like transparency, regular audits, and feedback loops. That's how we can identify bias, reduce its harm, and ultimately hold these systems accountable. And that really leaves us with this final, crucial thought. Maybe removing all bias is impossible, but removing ignorance is not. The first, and maybe the most important step, isn't finding a perfect magic solution. It's simply knowing that this problem exists and taking it seriously. The real challenge here, it turns out, isn't just a technical one. It's a human one. It's on us to stay vigilant, to keep asking the hard questions, and ultimately, to demand better.